My name is Mark Starovoitov, and welcome to my presentation, Role of AI in Level Design. Before I dive into how levels are impacted by AI, I would like to briefly point out the main points as to how AI has changed to become so widespread in recent years. The first major breakthrough was the invention of the transformer architecture in 2017. I highly recommend reading the article Attention is All You Need by Ashish Vaswani, who discussed in length about how transformers relies entirely on attention mechanisms to draw global dependencies between input and output. Transformers completely changed how AI models understand patterns, whether that's language, images, or even player behavior. Unlike older neural networks, transformers can look at relationships across an entire sequence, all at once. This means they learn faster, they understand context better, and they scale to much larger models. The second breakthrough was the massive improvement in GPU hardware. Early AI models were limited by slow training times and small memory. Modern GPUs, however, especially NVIDIA cards, can now process thousands of floating point operations per second, also known as FLOPs. This made training much more feasible, as well as also make real-time AI in games super efficient. Systems that used to take hours to compute can now run during gameplay, adjusting NPC behavior or generating content on the fly. The third breakthrough is scaling, both in terms of data and model size. Modern AI systems are trained on enormous datasets, and transformers scale extremely well in proportion to the amount of data that you have. The more you scale, the more generable and flexible the model becomes. With this combination of huge datasets and scalable architecture, AI is able to learn patterns that were believed to be impossible even a decade ago. Now that we've covered why AI has become so widespread, I would like to introduce the three major areas that I will be focusing on for the rest of my presentation. These are the areas where AI has had the biggest impact on level design in recent times, showing just how dramatically the field of game and level design is changing. The first area I will be focusing on is procedural generation. AI has made it possible to create massive dynamic worlds that feel different every time you would play them. Instead of relying only on handcrafted environments, designers can now use generative systems to build terrain, ecosystems, and structures at a scale that was not possible before. The second area is NPC behavior. Many AAA game studios, like Rockstar, focusing on building GTA 6, are focused on creating characters that feel more believable and reactive. NPCs can make decisions based on context, they can remember past interactions, and change their behavior over time, helping create worlds that feel alive and busy. And finally, we have the third area, which is adaptation. Specifically, adaptation towards the player. So if they are struggling, the AI system could monitor how they are completing the beats of the level and adjust it if it's too easy or if it is too hard as well. These are the three areas: procedural generation, NPC behavior, and adaptation. These form the foundation of how AI is reshaping level design today. Each one represents a major shift in how AI and how levels are designed and how players experience them. Procedural generation is the idea that game worlds are not built by hand, but instead are created by using algorithms and generative systems that produce huge amounts of content automatically. Modern AI has pushed this much further by allowing these systems to become more layered, more dynamic, and more responsive to player behavior. This paper, Generative AI for Dynamic NPC Behavior and Procedural Content Generation in Games, states, "We analyze the integration of large language models, diffusion-based generative models, and reinforcement learning across a multi-layered technical stack. This technical stack is the entirety of procedures from all the layers and dynamics. This is what the AI tweaks to generate new content, and for the example of No Man's Sky, it would generate a new planet." Now, No Man's Sky, which is the example I showed here, does not actually use neural networks. But every planet, every biome, every creature, and every weather system in this game is created through a combination of mathematical noise functions, environmental rules, and simulation logic. And it embodies the same principles described in the paper as having a generative pipeline that builds complex environments from a set of constraints and learned patterns. What makes this so powerful is how it affects the player. No two players will ever explore the same world. Procedural generation turns exploration into a core gameplay loop, and AI makes that loop feel endless. The second major area where AI transforms level design is with NPC behavior. In modern games, non-player characters are not just background elements, but they are active participants in the environment. AI has made it possible for NPCs to behave in ways that feel far more believable, far more reactive, and context-aware than ever before. The article Predicting Game Difficulty and Engagement Using AI Players explains that contemporary NPC systems rely on layered AI architectures. These include reactive behaviors, planning systems, utility-based decision-making, and simulation-built models. And when these layers work together, NPCs can evaluate their surroundings and make choices based on priorities and respond dynamically to the player, as well as their environment. A great example of advanced AI and NPC behavior is Red Dead Redemption 2. The NPCs in this game use a combination of behavior trees and utility systems, as well as environmental simulations to guide their actions. They follow daily routines, they react to weather, they respond to crime, and even remember their past interactions with the player. Their reactions are not random, but they're driven by layered AI systems that evaluate context and then choose appropriate responses. And this level of detail in character behavior and interaction has a huge impact on level design and to the player experience. Because, as I mentioned before, towns feel lived in, characters feel believable, and the world feels reactive. And that sense of authenticity is a direct result of the AI techniques. The final major area where AI has transformed level design is adaptation, specifically for difficulty, but it could also apply for a wide range of variables, such as changing the level geometry. Maybe if the player is struggling and doesn't know how to explore the level, then it will actually change and make it easier for the player to explore it. That could be one of the areas. But the main focus I had with this is adaptation specifically for difficulty. Instead of relying on fixed difficulty modes, modern games could also now include AI to keep players in a balanced and engaged flow state. The book I referenced, titled Artificial Intelligence and Games, explains that adaptive systems rely heavily on player modeling. So these systems would track things like stress, skill level, resource usage, and movement patterns that the player is doing while they are playing. And by analyzing this data, AI can then make informed decisions about how to adjust the challenge. This book describes this as something called a dynamic difficulty adjustment, where the game modifies the parameters during play to maintain engagement and to prevent frustration from the player. A great example of this is the AI director in Left 4 Dead 2. The director constantly evaluates how the team is doing and then changes the pacing of the game accordingly. It can increase or decrease enemy spawns, adjust the timing of special infected, alter the placement of items, and also control the music intensity. All of these decisions happen moment to moment based on how the players are performing. And this creates a gameplay experience that feels alive. No two runs will feel the same, since the director is always responding to the team's behavior, and this is exactly the kind of adaptive system that is described in the book. One that uses player modeling and real-time decision-making to shape the emotional rhythm of the game has a good sense of level design. So, to wrap up, I've shown how AI is reshaping level design across three major areas. First, we looked at procedural generation, where AI-driven systems allow developers to create massive dynamic worlds that feel unique to every player. Then, we explored NPC behavior. Modern AI enables characters to act in ways that feel believable, reactive, and context-aware. Finally, we examined adaptive difficulty, which includes systems like the AI director in Left 4 Dead, who monitors player performance. And this keeps players engaged and helps maintain a smooth flow state throughout the experience. Together, these areas show that AI is transforming level design from static environments into living systems that respond to the player. Looking ahead, we're likely to see more advanced applications from AI-assisted world-building tools that help players prototype entire levels instantly, to NPCs that learn from players over time, to fully adaptive game worlds that evolve based on long-term behavior. As AI continues to scale, it will give developers new creative possibilities and push game experiences into territory that we have never seen before. And it is definitely a very important skill to learn for this degree. Thank you so much for listening. These are all the sources. These are the three sources that I did. One for procedural generation. This is one that I did specifically for NPC behavior. And this is one that I did for the adaptation. And then for all of the images throughout my presentation, I have sourced them here. Thank you so much for listening.